So here we're going to look at quadrilaterals. What we're going to do is we're going to have a look at all the different shapes and we're going to rattle through a lot of their properties, some of which you'll need just now, some of which you won't, but it will come in handy in the future. Okay, but before we go on and have a look, we need to try and decide what a quadrilateral is. And we've already seen these before. A quadrilateral is simply a four-sided shape. Okay, so first one we are going to look at is the rectangle. Okay, so some facts about the rectangle then. We've got two pairs of equal sides. We've got four right angles. Okay, we've got two lines of symmetry. We've got one straight up and down and one horizontal line there. If we try and rotate it round, we see it's got order 2 rotational symmetry. Again, if we don't remember our symmetry stuff, have a look at that video, make sure we're happy with that. If we think about its diagonals, they bisect each other, so cut each other in half. And remember that our diagonal is a line from one vertex to another, right? From one corner of the shape to another corner. It is not simply a line that goes at a slanty angle. All right, so that's one of the things we need to remember from this. Looking at our next one then, we've got the square. Square actually just a special type of rectangle where it's got four equal sides. Okay, so it actually does have those two pairs. It just happens now that all four of them are the same size. So I've got four right angles. Here I have four lines of symmetry, one straight up and down, one across the way, and then my two diagonals are also symmetrical. And if we start to rotate it round, we can see, when we get all the way back to the start, that it has order 4 rotational symmetry. Once again, its diagonals bisect each other and they meet at right angles. And so there's a lot of things happening there in that square. Next on, we're looking at the rhombus, which is always hilariously spelled, but there it is, RHOMBUS. Okay, it has four equal sides here. Looking at this, we've got our opposite sides are parallel, so they'll continue on, those lines will never meet, get the same gradient there. We've got two pairs of equal angles, so using our angle facts here, our opposite angles are equal. I've got two lines of symmetry, and if I think about my rotational symmetry, it has order 2 rotational symmetry. Okay, looking at my diagonals here from one vertex to another, once again they bisect each other. And just like they did in our square, they bisect each other at right angles. Okay, another one that's always spelled hilariously is our parallelogram. Okay, so when we're looking at these, we've got two pairs of equal sides. Okay, just like before, we've got two pairs of equal angles, and again, looking at our angle facts, our opposite angles are equal to each other. The opposite sides are parallel, so again, if you keep those lines drawn, they should never meet. And if we rotate it round, we find it has order 2 rotational symmetry. And once again, I'm looking at my diagonals, and they bisect each other. Now, despite what we all seem to think, a parallelogram has no lines of symmetry. Okay, it doesn't matter how much you want it to have one, please don't draw one on, it doesn't actually have any. Okay, again, you can have a look at our symmetry video, make sure you're okay with what lines of symmetry actually are. Next one then is the kite. So again, when we're looking at these, it has two pairs of equal sides, so a trait that is becoming very common in our quadrilaterals so far. It has one line of symmetry, and it has one pair of equal angles. Looking at my diagonals, they meet at right angles, but this time they do not bisect. Okay, so they haven't cut each other in half. If we look at our vertical line, we can see that the top part there is much shorter than the bottom part, so they haven't bisected there. Okay, thinking about this one. Okay, is this type of kite, does it still have all these properties? Well, it's got these two sides that are the same size, it's got one line of symmetry, it's got one pair of equal angles, and its diagonals meet at right angles. Okay, it just becomes a little bit more complicated because now they don't meet inside the shape, but they do still meet there, and so yes, okay, that kite does still meet all of our conditions. Here, another one, again, another one that's always spelled hilariously is the trapezium. Okay, so it has one pair of parallel sides. Looking at that one, and that one, and again, just slight variations on what it is we're looking at here. Okay, if we look at this one down the bottom, okay, for it to be an isosceles trapezium, we want it to have one line of symmetry. So again, looking at the very first one we had, right, there is nothing that says that those slopey lines actually have to be the same kind of slope. But here, when we're looking at our isosceles trapezium, the expectation is that they are the same. And we can see that because the two angles down the bottom corners are the same size. And so for it to be an isosceles trapezium, triangle, a trapezium, that's what we need to have. And in doing that, that makes our angles at the top the same. So it has two pairs of equal angles. So in summary, okay, what we need to be able to do at this stage just now is we need to be able to name what each of the shapes are. So this is going to be one of our most important parts. We need to know what a rectangle looks like, a square looks like, a rhombus, a parallelogram, a kite, and a trapezium.